Hello, so today we are looking at Leetcode contest 159, and the first problem in that contest is check if it is a straight line, problem 1232, and the problem says we get an array of coordinates where each element of the array is just the two x and y coordinates and of a point, and we want to check if these points are on the same line. Basically, they make up a straight line in the xy plane. So the first example we have here is that we have these coordinates, and you can see here in the drawing they are on the same line. These ones are not. You can see here you can't make a line. And so how can we let's see how can we solve this problem. So how can we solve this problem? So the concept that is needed for this problem is the concept of slope. So for a line that has 2 points, so let's say we have this here, and then we have a line like this. If we have this point and this point, let's say this is C1 and this is C2, this one has x1, y1 as coordinates, this one has x2 and y2 as coordinates, then the slope in this case would be equal to y2, the coordinates of the second one, minus y1. Or actually, just to make these a little bit more clear, let's put the higher one to be C2 with x1, x2 and y2 as coordinates, and this one C1 with x1 and y1 as coordinates. So the slope would be y2 minus y1 divided by, this is the formula, divided by x2 minus x1. So the difference between the y coordinates divided by the difference between the x coordinates. And so we have this formula. So what we can do is calculate this first, because the problem guarantees that the coordinates array length basically would be bigger or equal to 2, right? So we have at least 2 points. So we can first calculate this. And then if we have another points, let's say we have another point somewhere, maybe here, let's say here, C3, to be able to identify if it's on the same line as these two, because any 2 points would be on the same line, right? Any 2 points, if you have any 2 points, you can put them on the same line. Now, when we have a third point, we need to make sure that it's on the same line as the 2 points. How do we do that? We just compute the slope again by doing, so let's say we have this one that has x3 and y3. So the slope there between, we can just compute the slope between that point and maybe, let's say maybe, C2, or maybe another point. Let's say if we have another one, C4, like this, that has x4 and y4, we could just compute the slope again for that one. So let's say slope 2, and that would be equal to y4 minus y3 divided by x4 minus x3. And whenever we find, so if we find any slope, like by examining the other points other than C1 and C2, any slope different, let's call it slope x or slope I, different than the original slope value that we computed for the first point, at that point we can just return false, because that means we don't have, they are not on the same line. So because any 2 points that are on the same line as another 2 points, they have to have the same slope. And if we don't find any occurrence of this, we can just return true. So that would be that would be a very simple solution. The only thing to worry about is, what if this value here is 0, right? If x2 minus x1 is 0, then we have a problem. We can divide by 0. So I will just handle that case differently by just saying that if x2 minus x1 are equal to 0, I'll just return 0 as the slope. And you will see that works with the problem. So let's type this into Leetcode and see if it passes. And in terms of like time complexity for this solution, since we would be just computing the slope for the first 2 coordinates, and then after that going through the rest of the coordinates, linearly computing the slope of 2 points each time, then the total time complexity would be just O(n), because we will traverse the coordinates list only once. So n is the length of the coordinates. So let's take a look at this and see if it passes Leetcode. Okay, so now let's type the solution. So the first thing we need is to define a function that computes the slope of 2 points. So let's say we have two coordinates, C1 and C2, and we have let's just unpack them here to get the coordinates, because that's what we will be using, right? So for the first coordinate, it's x1 and y1 for the first point. The second point would be, we will call it x2 and y2. So let's just put the values for those. This works in Python. It can unpack, when you put in parentheses, it can unpack this here with this portion, and then unpack this one with this portion, essentially. And now, let's say we need to return the slope, right? So the slope, we said, is just the difference between the y coordinates divided by the difference between the x coordinates. And we need to handle the case where if x2 minus, if the denominator is 0, then we have a problem. And so we said that we will just return 0 as the slope if this is 0. And then we could return the rest of the slope here. And then after that, now we just compute the slope that we want everything that we want the other points to be equivalent to. So we'll take the two first points and compute the slope for them. So that will be taken and this works because in the constraint we have that the length of the coordinates is at least 2. So we'd have the first one, and then we take the second one, and now we just return, or we could just, so we go through each two coordinates. And to do that, I can just do zip with the with this, and then with this. First, let me just explain why this portion here works. So let me just take something like this. So I have here just Python console. If I have, let's say, a list that is just has 1, 2, 3, 4, and I zip the list with the portion of the list that doesn't contain the first element, and let me just show what that does. So we'll print this as a list. So you can see here that we get 1, 2, 2, 3, and 3, 4. So what it does is it combines this and this one, and this one and this one, and this one and this one. So every point gets concatenated with every other point. Gets like grouped with every other point as a pair like this. And once we check the slope, if this was a point, once we check the slope of each 2 points together and we find that it's the same, then they are on the same line. So that's what we are doing here. And we will check that if the slope is the same. So let's take the 2 points and check that the slope is the same. If it's not, then that's where we have a problem and we need to return false. But if the slope is the same for all of them, we can return true. And from this, you could see that this is an O(n) solution. So the time complexity here is just O(n). In terms of space complexity, we are not using any extra space, only one variable, so space complexity is O(n). And that's pretty much it for this. So let's just run it. Okay, so that passes. One small change that we can make to this solution here to make it shorter. It's not really necessary, but just useful to know. So we can just use Python all notation instead, and say we want all points, each 2 points to have the same slope, right? Like this. And with this all here, whenever 2 points don't have the same slope, it will return false. it will return false, because this condition has to be valid for all of them for this to return true. So I'll submit that and submit. Okay, so that passes. One slight improvement, if we don't want to go through the two first coordinates again, it doesn't really matter because it's just one operation, but if we really want to, we could do this also. Yeah. Okay, so another slightly different way to handle the division by zero case that is definitely more like legitimate, let's say, maybe, than just saying it's zero if the denominator is zero, which is one thing we realize is we want the slope of every 2 points to be the same. So if we have, let's say, 3 points, let's say C1, C2, C3, which are three points here, then we know that what we need to verify is that the slope of C1 and C3 is the same as the slope of C2 and C3, right? They have to have the same slope. So what we can realize here is that the slope of C1, C3 has to be equal to the slope of C2 and C3, and this generalizes to more points that we add. If we add C4, then if we have also, let's say, C1, C2, and then another point, we add another point, and then C1, C2, C5. So we will fix these 2 points, and then each point will add it to them. Then the slope of C1, C4 has to be equal to the slope of C2, C4. And if these are equal, then it's equal to these. And you get the idea, all of them would have the same slope. And so let's just write the formula for the slope for each here. So the formula for slope is that what should happen is that, let's say C1, each one has x1, y1, and this one x2, y2, x3, y3, right? So here the formula is that y3 minus y1, this is the slope, divided by x3 minus x1, right? And for this one, it's y3 minus y2 divided by x3 minus x2, right? And so for these to be equal, then the product of these ones has to be equal to the product of these ones. That's just like elementary multiplication and division here. So that would mean that in our case here that x3 minus x1 multiplied by y3 minus y2 should be equal to this other portion of the multiplication here, which is that x3 minus x2 multiplied by y3 minus y1. So these has to be equal for every 3 points, for all of them to have the same slope. So what we'll do is just apply this to all the coordinates and make sure that it's true. So just pick C1 and C2 as the 2 first coordinates, and then just check that any other point Ci, by plugging that in place of C3, we'll have this equality here. If we do, then we have a solution. So let's type that into Leetcode and make sure it passes. Okay, so let's start the implementation for that solution. So what we need is, we need the 2 first coordinates, right? So, and we need their x and y values. So let's say these are the 2 coordinates that we'll take. So first it would be the 2 first coordinates, and in Python we can get these using this. And then what I need really actually is the x and y values. So let's just call this x1, y1 and x2, y2. And now we can just make sure that all of them have the same slope. So I could do the for loop and make sure that, so like this. So I would just do for a new points, right? Let's call it y3, x3 in coordinates. I could like do it like this because I want anything after the 2 coordinates that I already taken, but I could just also just keep it like this. But let's just do it this way. Now if I find any, so this is just the formula that we just saw in the overview. So it's just x3 minus x1 multiplied by y3 minus y2 should be equal to x3. If it's not equal, then we would return false. So minus x2 multiplied by y3 minus y1. This is the exact same formula, and if they are not equal, that means the slope is not the same, we can return false. Now if all of them have the formula valid, then we can return true. All right, and let's just submit this. Okay, so that passes. We can modify this slightly to use the all Python all thing that we saw earlier. So we just need this to be valid for all of them, right? So we could just say this, and that's for these, and we could return that. And that's pretty much the same thing as the for loop. So there is a small error. It should be equal, right? All of them should be equal, right? If we do different, then we can use any here, so that if we find any points for which they are different, then we don't have the points are not on the same line, right? So let's submit this, and that passes. Yeah, so that's it for this problem. Thanks for watching, and see you next time.